On to another AIME problem. This is the 2016 AIME 2, question 16. For polynomial p of x equal to 1 minus 1 over 3x plus 1 over 6x squared, define q of x equal to p of x times p of x cubed times p of x to the fifth times p of x to the seventh times p of x to the ninth, which is equal to sum, as I goes from 0 to 50, of a sub I x to the I. Then the sum of the magnitudes of the coefficients will equal m over n, where m and n are relatively prime positive integers. Find m plus n. Okay, so in here what I noticed was this. I'm not going to write it all out, but p of x, this first polynomial, is going to be 1 minus 1/3 x plus 1/6 x squared. P of x cubed is going to be 1 minus 1/3 x to the third plus 1/6 x to the sixth. P of x to the fifth is going to be 1 minus 1/3 x to the fifth plus 1 over 6 x to the 10th. And I guess I'll finish it off. I'm close. P of x to the seventh is going to be 1 minus 1/3 x to the seventh plus 1/6 x to the 14th. And the last one, I'm running out of colors, is p of x to the ninth, which is 1 minus 1/3 x to the ninth plus 1/6 x to the 18th. And what happens is when I multiply this across, I basically end up choosing one of the three terms from each of these factors, or polynomials for lack of a better word, to get into the product. And all of the even terms when I multiply, so let's say I want an even term, so I could do 1 times 1/6 x to the sixth times 1 times negative 1/3 x to the seventh times negative 1/3 x to the ninth will be even, because I will have an even number of these odd powers, which means that an even number of negatives multiplied together will be positive. 0 negatives is still even, still be positive. So all of the even power coefficients will be positive. And in order to get a negative power, I'm going to end up having to figure out, it's going to have an odd number of these odd powers. And so all of the odd powers will end up with negative coefficients. Now, in here, what happens is this is very similar to 1 plus 1/3 plus 1/6 to the fifth power. Because I'm really multiplying all these things together, 5 of them, and then just adding it all up. So if I just sort of took out all of the x's, and remember we talked about every single one of the odd powers will have a negative coefficient, so the absolute value, that's going to make it positive, so these will be the same. And I can just find this by finding this. Because I don't care what the specific coefficients are, I just want the sum of all of the magnitudes of the coefficients. And so 1 plus 1/3 plus 1/6 is 3/2 to the fifth power, 3, 9, 27, 81, 243 over 32, which gives me 275. Feel free to comment with questions, and I'll get 1 or 2 more of these up tonight.